Chapter 5, Section 6. Objective, learn to compare similar figures. Essential question, how do I use a scale factor to find side lengths and areas of similar figures? Vocabulary, dilation, center of dilation, scale factor. This is something to think about. Your pupils are the black areas in the center of your eyes. When you go to the eye doctor, the doctor may dilate your pupils, which makes them larger. So think about that picture and how the inside of your eye is getting larger and smaller, maintaining the same shape, but changing size. Same thing we talked about with similar figures, where we have two shapes that are the same image, they're just different sizes. Every dilation has a fixed point that is the center of dilation. To find the center of dilation, draw a line that connects each pair of corresponding vertices. The lines intersect at one point. This point is the center of dilation. You don't need to worry about this. For the purposes that we'll be using, the center of dilation will always be the origin, which means we can use the values as they are. By definition, a dilation is a transformation that changes the size, but not the shape of a figure. A dilation creates similar figures. Tell whether each transformation is a dilation. What we're looking for is, are the two shapes similar? So if we compare the ratios, 2 to 6 and 2 to 6, the ratios of the corresponding side lengths are the same, and the angles are congruent. Just a side note, what is the scale factor from the blue square to the red square? From blue to red, from 6 to 2, we have to multiply, so we would have to multiply by 1/3. Let's see if these two triangles form a dilation. We have triangle ABC, which has sides of 4 and 5. Triangle A prime, B prime, C prime, sides of 2 and 3. Our ratios of the side lengths are not the same. Therefore, we would say that these are not a dilation. If there's no dilation, if there are no similar figures, there can be no scale factor. Let's look at the definition of a scale factor. The scale factor describes how much a figure is enlarged or reduced. It represents the ratio of a length on the image to the corresponding length on the original figure. In your notes, scale factor equals the number you multiply by to create the new image. I can't emphasize how important that word multiply is. So often we want to divide with scale factors, but remember, scale factor is a value that's commonly represented. We have to know what that value stands for. If we change whether we're multiplying or dividing, our number no longer has the same meaning. To get the scale factor, divide the corresponding lengths of the two figures. Dilate the figure by a scale factor of 2. Before we do that, let's think about what that means. Scale factor of 2 means we're going to enlarge our image. What are the side lengths of the new image? So here's our new image. The little dashes mean prime. That allows us to correlate A with A prime as the same angles. So if we're going to use a scale factor of 2, we multiply all the side lengths by 2. So now we have 8, 8, and 12. If we dilate the figure by a scale factor of 0.5 or 1/2, what are the side lengths of the image? We're going to be reducing our image by 1/2. So we multiply 4 times 1/2 is 2, 6 times 1/2 is 3. Dilate the figure by a scale factor of 1/2. What are the vertices of the image? We can also dilate, even if it's not side lengths, we can do the same thing for vertices. So we need to start with the original points. First, we need to figure out what are the coordinates of A, B, and C. A would be located over 4 up 5, so at the point 4, 5. If we dilate that by a factor of 1/2, that means we multiply those points, both those numbers, by 1/2. Half of 4 would be 2. Half of 5 would be 2.5. Let's do B. B is located at 8, 5. Half of 8 is 4. Half of 5 is 2.5. And point C. C is located at 4, 9. Half of 4 is 2. Half of 9 is 4.5. Means that if we were to graph those three coordinates, we would form our new image, which would look like that. And this shows how our center of dilation is the origin. Biggest thing to keep in mind is when you are changing shapes. So for example, if I want to reduce a rectangle down from 7.5 to 4, if I need the scale factor from the smaller to the larger, I would take 7.5 divided by 4. However, if I wanted to go larger to smaller, I need to flip that around, do the reciprocal of 4 divided by 7.5. If you forget which one's which, use your common sense, find both values, and determine which one would make my shape larger or smaller based on what we're looking for. At this point, make sure your notes are filled out completely and that you've written questions on the left-hand side. Review your notes. Complete the summary before class.